Okay, so I'm giving you this function and I'm telling you to take the derivative of the inverse of this function. Well, if you know what inverses are, it's basically you're switching the x and y values of this function and then solving for y. Let me demonstrate. Instead of using f of x, I'm going to use y equals 3x plus 4. And now I'm going to switch x and y. So, x equals 3y plus 4 is my inverse. But since we can't write functions like this, we have to solve for y. So, I'm going to get x divided by 3 minus 4 thirds equals y when I solve for it. Now, this is a complete inverse of the original function. So I'm going to use inverse notation. Now, to take the derivative, I simply take the derivative of this expression over here. So, the derivative of the inverse of this function is basically 1/3. Easy, isn't it? But what if I give you something like this? And so on. This is a really hard expression to, switch the variables and then solve for y. Because you have y to the 5th, y to the 3rd, y to the 2nd, and if I add a constant here, it's going to be really messy. So, what do we do then? Well, let's find out. Yeah, so because it is very difficult to take the derivative of the inverse now with this kind of a function, we're given this formula 1 over f prime of f inverse of x, where we can take the derivative of the inverse at specific points. And this is useful to a certain extent, that is identifying the derivative of single points, which is why we're always given specific values for a problem like this. Because again, the f inverse of x is really hard to get in an equation form because of how many times you get y values for something like this. Now, there are scenarios where you don't need specific points, and in those questions you will not get them, but you can still use this formula to get the inverse derivative. So, let's solve this function here. So, let's say I'm asking you to take the derivative of the inverse at point 2. Right? So, now, what we're going to do is wherever we see x, we're going to plug in 2. Okay. So, f inverse of 2. That's basically saying that for my inverse function, the x value, right? So, for the inverse function, an x value is basically the y value of the actual function. So, I'm going to look in this place, and I see that the y value for the actual function is over here. Now be careful though. Here, this is the actual function because I did not put the -1 here. But sometimes they could give you the inverse and they expect you to take the x value. So be very careful with that, right? So now what we do is we look at the x value, because the x value is the inverse function's y value. So f inverse of 2 is basically 7. So I'm going to write that again. 1 over f prime of 7. And now it's simple. F prime of 7 is given. equals 8. So this would just be 1 over 8. Very easy to solve. And now, before we move on to solving that formula without having to deal with actual numbers, let me first give you the inverse trig derivatives, which you have to memorize. And I will say that these are the hardest things to memorize in Calculus 1. So, for sine, it's 1 over square root of 1 minus x squared. Now for cosine, it's basically the same thing. That's the best part about trig. It's basically the cofunctions are negative versions of the sine, tan, and secant functions. So for cosine, it's basically this again, but it's negative. So you're really memorizing 3 variations, but the cofunction will have the negative. So let me show you. So for tan, it's basically 1 divided by x squared plus 1, the easiest one to memorize here. For cotan, it's negative 1 over x squared plus 1. And the hardest ones to memorize are the secant and the cosecant functions, but you'll get used to them. 1 divided by absolute value x square root of x squared minus 1. Again, the negative version of that is the cosecant. Now, these trig functions will appear sometimes in integrals when we get there, which is calculus 2. But I would say that they're kind of rare, but they can appear with the inverse derivative formula. So it is really, really necessary to memorize these, as I highly recommend that you probably do these on your own, write them on your own sheet of paper, and get used to them. Because after a while, you'll find that they're not that bad to memorize and explore. Now, if I were to ask you the same question with f of x being 6 sine of x, you can do it both ways. The first way I showed you, where you take the inverse directly, I could say f inverse of x is equal to, okay, I'm going to write this as y equals 6 sine of x. So x equals 6 sine of y, and then it would be x over 6 equals sine of y, and the inverse of sine is arc sine, or sine to the negative 1, so you're basically writing x over 6 equals y. So basically the same thing here, sine negative 1 x over 6. And then you take the derivative of that, and the derivative is going to be this, so we're going to write 1 over 1 minus, so let me just write that here. Equals 1 over square root of 1 minus x over 6 squared, and you have to do chain rule, so I have to multiply that by 1 divided by 6. And that's how you do something like this. Or you could do it the second way, using the formula. Now, the second formula, for all you curious people out there. And I'll tell you this. This involves the same step as the first one to find f inverse of x. And then you do plug it into this formula. But you have to do additional steps that feel very unnecessary. So, I did get f inverse of x, which is sine inverse x divided by 6. But now, instead of just taking the derivative of that, I have to do the derivative of basically 6 sine of x with this integrated into it, and then 1 over that. So in other words, I have to do this. 1 divided by 6, so the derivative of 6 sine inverse sine x over 6. So I have to take the derivative of that. So it's a chain rule. Okay, so that means I have to get 6 cosine and keep the sine inverse inside it. X over 6. And then multiply that by whatever we got before, 1 divided by square root of 1 minus x over 6 squared, or 6 times square root of 1 minus x over 6 squared. So when you do that, the 6's do cancel out, right? So you get cosine times sine inverse of x over 6, or cosine of sine inverse x over 6 times 1 over 1 minus x over 6 squared, and all of that over here. So basically your answer is going to be this very complicated version right here, and I put the square root on top, 1 minus x over 6 squared. I think I put that right. But it's basically the same thing, and I don't know why you would ever do this on a test, unless you're just trying to explore in your free time. So, there you have it. That's how inverse derivatives work, and I strongly recommend you to use it when you're given points, and there's no other way to solve the derivative. But if you're not given points and you're given a straightforward equation, I strongly don't recommend you doing it. As you can see, it's going to overcomplicate everything and make a big mess, and sometimes it could lead to mistakes. So yeah, please don't do this unless you absolutely need to.